Hi everyone, I am JULKA. Today's topic is three-dimensional geometry. Here we will talk about basic of three-dimensional geometry. In 3D, we have three axes, x-axis, y-axis and z-axis. At x-axis, y and z equal to 0. If we take any point on y-axis, z and x equal to 0. And at z-axis, we have x and y equal to 0. We have xy plane, is also known as xy plane. Here z equal to 0. Yz plane means yoz plane. Here x equal to 0. If we take any point on zx plane means zox plane. Here y equal to 0. We can explain with the help of an example. Let there is a cube of HA. Means side is A. Here OA, OB and OC equals to A. So we have A point which is on x-axis. It is A0, 0 because here y and z equal to 0. B point on y-axis, so it is 0, A, 0. C point on z-axis, so it is 0, 0, C. We have D point on xy plane. Here z equal to 0, so point is A, 0. E point on yz plane, so the point is 0, A. And the F point on xz plane, here y equal to 0, so F is A, 0, 0 and P in a space. So the value of P is A because to reach P we have to cover OA, AD and DP. OA is A, AD is A and DP is A. So the P point is A. First is distance formula. Suppose we have 2 points, P is x1, y1, z1 and the Q is x2, y2, z2. Distance between PQ can be calculated using formula in the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We can explain with the help of an example. Find distance between point P 2, 3, 5 and Q 7, 9, 13. Here x1, y1, z1 is 2, 3, 5 and x2, y2, z2 is 7, 9, 13. Using formula of PQ, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square in root. After calculation we get 5 root 5. Next example. Find the length of perpendicular drawn from the point 3, 4, 5 on y-axis. Point P is 3, 4, 5. When we draw a perpendicular to y-axis, here x and z equal to 0. So the point is 0, 4, 0. We say it is Q. And PQ is using formula in the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square by inserting value of x1, y1, z1 3, 4, 5 and x2, y2, z2 0, 4, 0. We'll get the answer root 34 units. Next example. Find the length of perpendicular drawn from point P 6, 8, 7 to zx plane. At zx plane y 0. Let Q be the photo perpendicular on zx plane. So Q is 6, 0, 7 because here y is 0. Now find PQ using formula in the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, where x1, y1, z1 is 6, 8 and 7 and x2, y2, z2 is 6, 0 and 7, and after calculation we get answer 8 units. Whenever we have 3 points A, B and C, first find AB, BC and AC. If sum of any two sides equal to third side, then ABC are collinear. Second point, if any two sides are equal, then triangle ABC is an isosceles triangle. Third point, if all sides are equal, then triangle is an equilateral triangle. And the fourth point, if sum of square of two sides equal to square of third side, then triangle ABC is a right angle triangle. And if we have 4 points A, B, C, D, find AB, BC, CD, DA, AC and BD. First point, if all sides AB, BC, CD and DA are equal and AC and BD diagonals are also equal, then it is a square. If all sides AB, BC, CD and DA are equal but diagonals are unequal, then it is a rhombus. If opposite side, if AB equal to CD, BC equal to DA and diagonals AC equal to BD, then it is a rectangle. If opposite side means if AB equal to CD, BC equal to DA, but diagonals are not equal. This implies AC is not equals to BD. Then it is in parallelogram. So always remember these points. Next example. Find the point on y-axis which is at a distance of root 10 units from the point 1, 2, 3. Because we want to find a point on y-axis, at y-axis x and z 0. So let q 0, y, 0 be any point on y-axis which is at a distance of root 10 units from the point p 1, 2, 3. So here pq is root 10. Find pq using distance formula in the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, which is equals to root 10. Now squaring both sides and we'll get 1 plus 2 minus y whole square plus 9 equals to 10 and 2 minus y whole square equals to 0. Square root both sides, so the 2 minus y equals to 0, so value of y is 2. So the required point is 0, 2, 0. Next is section formula. If R divides P, x1, y1, z1 and Q, x2, y2, z2 internally in the ratio of m is to n, then the coordinates of R is mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n, comma mz2 plus nz1 divided by m plus n. But if R divides externally in the ratio of m is to n, here PR upon QR is m upon n. So the ratio is m is to n. So the coordinates of R is m times of x2 minus n times of x1 divided by m minus n, m times of y2 minus n times of y1 divided by m minus n, comma m times of z2 minus n times of z1 divided by m minus n. If R is the midpoint of P and Q, then the coordinate of R x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, comma z1 plus z2 divided by 2. Last example. Find the ratio in which line joining P 2, 4, 5 and Q 3, minus 2, 7 divided by zx plane. Let R be any point in zx plane which divide P and Q. P is 2, 4, 5 and the Q is 3, minus 2, 7 in k ratio 1. So coordinates of R is 3 times of k plus 2 upon k plus 1 minus 2 times of k plus 4 upon k plus 1 and 7k plus 5 upon k plus 1. But R lies on zx plane. At zx plane, y is 0. So minus 2k plus 4 upon k plus 1 equal to 0. After calculation, get the value of k 2. So the required ratio is 2 ratio 1 internally. So R divides PQ in the ratio of 2 is to 1 internally.